Hey everybody, welcome back to the Pareto web series where we are going to walk through the creation of a full stack React and Node.js based application using Amazon Web Services. So in this episode we're going to walk through our serverless REST API that's going to be in charge of querying MongoDB for retrieving information about our users and the progress that they are making within the Pareto experience system. So the file that you're looking at here on the left, this is called the serverless.yaml file. So this is the file that's going to determine the configuration options for our serverless API. So we're naming the service to be called Pareto. We're including a couple of plugins. We are customizing our Webpack configuration. For those who might not know, Webpack is a way of bundling our code to make it smaller and excuse me, and to bundle the code and to make it more performant. Here we are listing information about our provider, which is Amazon Web Services. We're specifying that we want Node.js 8.1 to run. Although we could theoretically choose to run 6 if we really wanted to. We are creating the production stage. So this service is going to, when deployed to a production stage, but we can specify dev or QA. The region here, well, we actually want to deploy it to US East 1, so let's go ahead and change that real quick. The memory size of 128 megabytes is specified, as well as a timeout of 10. So this timeout means that after 10 seconds of operation, if the request has not yet successfully completed, the server is going to drop the operation. Below here, we actually list out our functions. So this is our hello world example. It's more of a sanity check that we can query to make sure that things are somewhat working. And here we list out the different functions that we are using. So we have two main APIs. We have our users API and we have our experience API. And both of these are CRUD APIs. And CRUD stands for create, read, update, and delete. So these are effectively the only 4 things you can do with data. You can create it, you can read it, and you can update it and delete it. That's essentially it, and most of computing, all of computing, is really just based around those 4 operations. So as you can see, we have a function to create a user, to retrieve information about one user, get one user. We can get all users. We can update a user, we can delete a user, we can get all students, which is getting all users that have a type of student, and as well as a get all instructors function. Similar things for our experience section, create, read, update, delete. So the handler, this specifies the name of the function inside of the user's JS file. And here we're specifying an environment variable called Mongo. So an environment variable is usually a key that is important. Usually it's a part of authenticating access to a certain service. In our case, this environment variable corresponds to the connection link to our MongoDB instance hosted on MongoDB's official service. The name escapes me. Essentially, how we're actually accessing this is the serverless framework, which is the service that we're using to create these serverless functions, has a built-in integration with AWS's parameter store, which is a subsystem of AWS Systems Manager. So here in AWS, you can create a global environment variable that you can access In the serverless framework, this is how you would access it here, but you can access it through other ways, through the AWS command line, and more. Essentially, it's just a way of storing important information, such as the username and password for the admin to be able to log into Mongo, and it's stored here. I'm not going to click into it because I don't want to show you the password, but this is accessible by going to Systems Manager and clicking into the very, very, very bottom left, all the way down here, right? So, moving on, so we have that environment variable, and each of these functions has an events section, and we're specifying an HTTP event, and HTTP events can come in a couple of different forms. If you're trying to fetch some data, if you're trying to get some data, you can use what's called a GET request to retrieve it. If you're trying to create data, if you're trying to write data to a data store, you would use something called a POST request. If you are trying to update data, you would use something called a PUT request. And if you're trying to delete some data, you would use a DELETE request. All these GET, POST, PUT, DELETE, usually they're all in capital letters, but here obviously they're all lowercase. CORS, this stands for Cross-Origin Resource Sharing. So why is this important? Well, by default, the internet does not allow for a URL to receive incoming requests from a different URL. So by default, Google.com does not allow your computer to send it a request. However, Google can say, okay, I want to allow other IP addresses, other URLs, essentially, to send a request to me, and I want to be able to process it. So they turn on cross-origin resource sharing. That's why we're setting it here to true. And the path is the route of the server that we need to send the HTTP request to activate the business logic within this specific function, this handler function. So as you can see here, this one, it says, if we want to get one user, we have to send a GET request to our server URL /users/ID. Now this is a dynamic ID, meaning that we will plug in the ID in our actual HTTP request, and that parameter will be dynamically read, like so. So that is essentially what the serverless YML does. The serverless framework makes it pretty darn easy to configure everything, right? So we can configure the provider, the runtime, the stage. We configure our separate functions, right? And it's all tied to what the actual handler functions are. And so here, this is what our users function looks like, our users functions, and they're very, very similar to our experience functions. They're virtually identical. And as you can see, we have modules.exports.create, get one, get all, update. So they all tie in with the serverless.yml, right? Let's go ahead and put them side by side here real quick. So we can see create, get one, right? So what's going on here in these functions? So we have a function called create, and that create function receives 3 parameters here, right? So it receives an event, there's a context, and there's a callback. So the event is the object that the API endpoint is receiving from the front end. So let's say that we are creating a new user. And so the UI in our React application has some forms for the user's first name, last name, etc. Right? And they fill out the form and they click the submit button, and we take the information from those forms and we send it to our URL/users with a post request. Here, what we're doing is we're connecting to the database, and then we are creating a user based off of the parameters inside of the event body, the request body. The event is another word for request, essentially. What we're doing is we're using JSON parse, because this right here, this event body, is actually a string. It's a JSON string. But in order for us to turn the values of that string into something that our JavaScript functions can work with, we have to parse that JSON string into a JavaScript object. And that JavaScript object has to match the model that we created for our user here. So the model has to have an attribute called fname, lname, mentor, XP, apprenticeship ID. It doesn't have to have literally all of these. However, it has to, if there is a value that we are creating, it must be defined here. If we try to send some sort of attribute, such as, let's say, mname, middle name, but we don't define an mname attribute here, MongoDB will not save anything under mname. So we have to spell out what attributes our model has here, similar to the experience, right? So we're parsing the event object, right? And then we're creating a user. And then what we're doing here is we're chaining. We're after this, we're taking the returned value of this function, which was the actual user that was created, and we're running a callback that essentially is going to return this status code of 200, meaning that it was successful, along with a body attribute inside of the object that has the successfully created user. So essentially what we're doing here is the request, where the user in the front end submits the information for the new user to be created. MongoDB processes this and creates a new user. And then in this callback, the server is responding to the user, to the front end. It's sending this back to the React app. It's saying that the status code is 200, meaning that it was successful. And it's sending back the actual user that was created. So we could then take this user object and we could store it inside of the state of our application. Now, if somewhere along the line here there was an error, this .catch block is going to catch that error, and then with this callback, it's going to return this to the application. It's going to return these headers that the content type needs to be plain text with a body that says we could not create the user. So this is all well and good, and as you see, it basically follows the same pattern. The business logic changes a little bit based on what we're doing. So here, when we're creating a user, we're doing user.create. When we're trying to get a user, when we're trying to retrieve that information, we're using the find operator, which Mongoose provides, for us to be able to find the user with the ID that was the event.path.parameters ID. So this is the path parameter of ID. So it's essentially we're making a request to this endpoint, and based off of the ID that we're including, that's the variable that it uses to actually perform the search, and then it sends it back to us, or catches, right? And so it follows the same pattern: get all, update, delete, etc. So now that is essentially the API, the serverless API. Remember, it's packed in something called Webpack, and this is the Webpack configuration file to bundle and minify the code. I guess here we're not minimizing the code, but what we're doing is we're basically bundling it to improve performance and reduce size. Here in the db.js, what we're doing is we are reusing our login and connection information to MongoDB over multiple requests. So if we didn't have this, what would happen is that every single time a user sent a request to this API, we would open a new connection with our MongoDB instance. And our MongoDB instance only has room for 100 concurrent connections at the moment. So that means that if a user, or even me, during the course of testing and debugging the application, if I refreshed the app 100 times, it would pretty quickly stop working, right? Because it would just be too many consecutive API requests. So what we're doing is we're actually reusing the existing database connection by logging in to Mongoose and tracking that we have in fact connected within the last essentially 10 or 15 minutes while the serverless container is still active. And this information is stored inside the context of the Lambda container. So anyways, so we have this, right? And we want to go ahead and deploy this stuff, right? Now you're probably wondering, how the heck did I do that? Well, I just ran the command npm install -g serverless. So I globally installed the serverless framework, and I just installed the npm dependencies of the package itself. So now what I want to do is I want to go ahead and deploy my APIs. So let's see. Whoa! What happened here? Oh my. Something's wrong with handler.js. Well, you know what? We actually don't really care about this because this is just the default example that was included along with the serverless framework, and we're totally not really using it. So let's just go ahead and delete it. And let's go ahead and run this command again. If you want to access the most recently executed command, all you have to do is press the up button and deploy. So let's see what happens here. Okay, it's bundling with Webpack. Seems like there weren't any errors, and so now it's packing the external modules. And it looks like things are working. So when this is deployed, this is going to basically be created as some zipped up JavaScript files, and it's going to be deployed to an S3 bucket. And that S3 bucket, whenever API gateway is triggered by an HTTP request to a route such as /users/ID, it's going to go into that S3 bucket, unzip the files, extract the function that's associated with this path and execute it. So as we can see here, yep, updating prerequisite file to S3. And here it's updating CloudFormation file to S3. So remember, Amplify and Serverless Framework essentially at the end of the day are just abstractions on top of CloudFormation, which is the proprietary style of resource templates that Amazon uses. So, you know, as I explained in the last episode, essentially it's just a series of JSON objects or YAML files that lay out exactly how a resource is supposed to be configured, right? Kind of like here where we say, oh, we want to have the runtime be 8.1, we want to have the stage be production, the region US East 1, etc. So we're deployed.